Thank you for sticking around to the second day and after lunch. My name's Will Law. I'm from Akamai. I'm joined by Jeff, Richard, and Ross this afternoon. And we hope to give you a good presentation on building an open source DASH-AVC 264 player. It's a bit of a mouthful. We're going to be talking about Dash today. We're going to talk about MSC as a delivery solution. And I'm going to give a very quick overview of some of these subjects so we're all on a level playing field. And then I'll let the panel actually educate you on some topics they're very familiar with. We're trying to cook up something delicious here, and we have three ingredients to do it. We've got MPEG-DASH, we've got MSC EME, and we've got DASH.js. You may not know what these are. I'm going to describe very briefly what our core ingredients are, and then we'll see how they're mixed by our panelists. The MPEG-DASH, we've heard a fair amount in the show already. There was a session yesterday. It's an ISO-based standard for adaptive segmented delivery over HTTP. It takes HLS, HDS, and smooth, blends them, adds in some new features to produce an ISO-backed standard for delivering media. There's one slide I like to show about Dash because from an engineering point of view, it really describes what it looks like. There's a manifest. It's a list of the content. It contains a sequential list of periods. Okay? Inside each of these periods is what's called an adaptation set. It's a view onto the content. So if that's a football game, you might have an adaptation set that's a camera down on the field, another one that's a camera from a blimp. They're different views onto the same event. Each of those adaptation sets can then be represented by many representations. These are typically various bit rates. I might have 6 or 8 bit rates for the camera on the field, another 6 or 8 for the camera in the sky. And each of those representations is comprised of a series of segments of either audio, video, or text-based data. And these can be physical segments, they can be chopped up on a server, or they can be virtual ones, they can be range requests into a contiguous file. So that's a very high-level summary of the technical side of MPEG-DASH as a standard. What does it look like in real life? I know it's an eye chart, but that's a manifest file for a 3-hour movie. So it's a very concise way to represent video. And this has 3 bit rates for video and 1 for audio. It has a lot of highlighted features. I'm not going to read them all out, but it's essentially an ISO-based standard versus one that's tied to any particular company's implementation. It's really robust over TCP and HTTP delivery. It supports various types of encapsulation, efficient trick modes, advertising insertion. So it's a very modern and current way to deliver video. I'm not going to go into those. DASH-AVC 264 now is a restriction because Dash is a very broad standard. To make it useful in the real world, we need to tone it down. We need to say, let's pick this, the low-hanging fruit, and implement this in a certain way. And that's what a group called the Dash Industry Forum has done. And that's this rather convoluted name, DASH-AVC 264. It's basically taken Dash, married it with a codec, because Dash is codec agnostic, made some limitations around how you can address the segments, whether you allow muxed or non-muxed content. It enforces common encryption on the DRM side, forces closed-gop switching, and what we have is a common set of Dash. And you're going to see that the Dash, all 3 panelists are delivering today, essentially abides by these restrictions. And I'm switching now to a slightly different topic, which is MSC. So this is a video tag in a browser. It's a very generic implementation of it. I simply take an MPEG-4, it's got a source attribute, I put it in and it starts playing. That's progressive video. Now, if I'm on Safari under iOS or under Mac, I can supply an M3U8, and the browser will automatically deliver adaptive bitrate to me. But I don't have any control over how it's buffering, how it's changing, or what sort of failback mode it might go into. That is the video element as we know it today. Now, the W3C is in final, or it's past final draft now. I think it's right on the standardization track. On top of your source element, you don't have to provide a file URL. You can set up something known as a media source. And this media source, in turn, supports source buffers of 3 types, video, audio, and text. Now what I do is I take that MP4 file I had before, and I break it up into video, audio, and time text data. And then I do that all in JavaScript. So JavaScript is grabbing a manifest. JavaScript is using XHR to grab these elements. And then it's feeding them down to media source. And when it's built up enough buffer, my video plays back the same way. So to the end consumer, it looks identical. But to developers, what it's done is given us total control over the format we use to deliver the content, how we buffer it, how we switch it, how we adapt it, how we extract information from it. It's a much more flexible solution. So this is known as Media Source Extensions, or MSC in abbreviation. And again, we're going to see how this is actually used in practice across many different environments. Now, Dash.js, as you go into that solution, what you can raise your hand and say, whoa, to make that work then, I need this JavaScript that's doing all of this, the JavaScript that's grabbing a manifest, JavaScript that's doing bitrate adaptation, and figuring out sequencing and scheduling of segments. This is fairly complex player building stuff. And if I'm a man in the street, how on earth am I meant to build a player for this? So it would really make sense if there was a common player that did this. So we could take an MSE browser, we could grab this open source bit of code, stick it in, and very quickly get a fully fledged adaptive segmented player. So that's what we've built. It's called the Dash.js project. It's on GitHub. There's a link for it here. It works under Chrome at the moment, under IE 11. More browsers are coming out with support. We'll talk about that as well. It's free to use and to extend. It's a BSD3 license. It plays back the DASH-AVC 264 format, and there's a number of players already. So we're going to see different implementations of it today and talk more about how the project is organized and also how you can participate in it if you so wish. I have some excellent panelists with me today. There's Jeff Tapper, Senior Consultant for Digital Primates. Richard Lader, Staff Web Developer and Tech Lead Manager for the YouTube Player Infrastructure Group at Google. And Ross Gardler, Senior Technical Evangelist, Microsoft Open Technologies, and also President of the Apache Software Foundation. So I'm going to get off the stage and allow the real guys to take you through the session. I'm going to sit down there and enjoy it as much as you do. After this, we'll come back for questions. Each guy's going to do a 10-minute presentation, and then let's have questions up at the end. OK, Jeff, switch yourself.
Hi. Hi, I'm Jeff. And so I'm going to talk to you a little bit about the details of the Dash 264, the Dash.js player. So as Will mentioned, Dash.js was originally built as a reference player for the Dash Industry Forum. And so in order to build the Dash.js, there's a handful of other frameworks that we made use of that you can see here. The ones in red at top are the actual core things that you need to use the player. The rest are pieces that we've used to assemble the web page that the player currently sits in. And actually, really quickly, let me just jump over and show a quick sample. So here is the page, and this here is just our Dash.js player. And so as it's playing, we can go to full screen and see our playback here. And what's really happening, if I open my developer panel, we can look at the timeline, at the network, and see, tell me it's not all cached. Well, we should be seeing the individual segments coming in. I'm afraid it's all cached because I have already been running this here locally. But effectively what's happening is the individual segments are coming down one at a time and being handed over through the media source into the HTML tag. So let's talk a little bit about how this all works. So ultimately, at the high level, the class structure of the Dash.js project, there's two primary packages. There's the core streaming package, which is ultimately responsible for communicating with the browser and for knowing how to interact with the media source extensions. And then we've got a separate package specifically for handling anything that's specific to Dash. The reality of why we've done it this way is that there's a number of other HTTP segmented formats that are available, and in theory, the same structure could be used, and we could just build out an HLS package for handling HLS, or a smooth streaming package, or HDS, or whatever else we might want. So that's why we built it in this fashion. In the core streaming package, the main class that you'll interact with is the media player JS, and that's actually the one that is responsible for interacting directly with the media source extensions. So ultimately, it gets a reference to the video tag, so it knows how to interact with that, and it knows what the URL is. We're using dependency injection, so our context classes set up our dependencies for us, so our context.js does all of our mapping so we know which classes get used and when. Our stream.js class is responsible for loading and refreshing the manifest, creating a series of buffers, of managers, the buffer manager, and listening for events from the HTML video object itself. A convenience class, our debug.js class. The buffer controller is ultimately responsible for determining how much content we have in the buffer and when we want to start getting more content. We have a couple other core classes here. The manifest loader is obviously, from the name, responsible for loading the manifest. and returns the parsed manifest object. It works with the parsers to understand what's in the manifest. And the fragment loader is the one that's responsible for getting all the individual segments, all the individual pieces of data, making the request for those. And of course, one of the core points of Dash, it being adaptive, we have an ABR for our adaptive bitrate logic, the controller there, that is responsible for determining whether or not the current bitrate is adequate, whether we should switch up or switch down. And it does that through managing a series of rules. Again, this is built to be extensible, so the idea is there's currently about a dozen people working with Dash.js, and that many of them are developing their own sets of rules. Dash.js currently has 3 or 4 fundamental rules that provide the basic logic for the adaptive bitrate. At the most core of them is the download ratio rule, that effectively anytime any file is brought into the player, it's measuring how big is that file versus how much time did it take to download. And using that, we're able to figure out what we think the network throughput is, and we're able to figure out, is this an appropriate bit rate, or should we suggest a change up or change down? Another rule that we have is the insufficient buffer rule. If our buffer looks like it's going to start running dry, this rule can make suggestions, hey, we don't have enough content, we need to switch down, we can't get things in here fast enough. There's a third rule that we make use of here, the limit switching rule, which basically prevents it from making decisions too quickly and just constantly jumping from the top bit rate to the bottom bit rate back and forth, which is, if any of you have ever written ABR logic, you'll know that happens far more often than you ever want it to. So we have something in there just to limit that. And so ultimately, that's the way that our ABR logic works, is that we've got an array of these rules, and each rule makes a suggestion for whether it should switch up or switch down. And as I say, that's all core to the streaming package. Regardless, none of that is anything specific to Dash. All of our Dash-specific logic is within the Dash package. Now that, of course, contains a Dash-specific context, which again, it's our dependency injection, does our mappings. It tells us specifically how do we want to, what class are we going to use to parse our manifest and things of that sort. What class we want to use as our index handler and our extensions and things of that sort. So the parser, of course, is responsible for taking our manifest and returning a JSON object. That from that JSON object, we're able to get all the individual pieces that we know, and really it's doing a flattening across the manifest. As Will was describing before, there are dozens of different ways within the manifest of describing the individual segments and where they are and what bit rates, and sometimes it's in a template and sometimes it's in a timeline, and ultimately our parser will take all of that and normalize it. So regardless of how the manifest was being described, we have one structure that we can work with as a common code base throughout. Our Dash handler JS is the class that's specifically responsible for loading or for knowing which segment to request next. And the idea, there's a couple core methods in here. The two that you'll interact with most frequently, or that get called most frequently, are the get next segment. Assuming you're playing back linearly, one segment's done, you want to get the next segment, it simply tells it get next segment and takes as an argument what quality. The other one, if you're performing a seek, is get segment request for time. So in that, you're going to tell it how many seconds into the stream you want to be and at what quality. And ultimately, what this is going to do is this is going to return to us a reference for what file we want to load. So ultimately, we take all of these classes, and it's built to be hopefully easy to use. So in order to use Dash.js, the core flow looks a little bit like this. In your code, you're going to create a context. You'll create a media player instance. You'll initialize your media player and give it the manifest URL. You'll call startup on it. You'll attach the video element to it, and then you'll call play or set autoplay to true. And that's really all it comes down to in order to start working with this and to start using this is these few steps. And code-wise, it looks like this. Right? So in the Dash.js player, we start by, we're just getting a reference to the video tag itself. We're creating an instance of our Dash context. We're passing the context into our media player, starting up the player, attaching the video, and setting autoplay. And really, to get started, it's as simple as those 6 lines of code to start using Dash.js. So that's all I have for the moment. I will pass on next to you
Richard.
next. You next. Yeah. Excellent.
Hi. My name is Richard Leiter. I'm the tech lead manager of the YouTube Player Infrastructure Group. We're the people who work on the plumbing below what people click on when they play a video at YouTube, if they click. I have a confession to make, and that confession is that YouTube uses its own players for Dash playback. And so YouTube is a friend of the Dash.js project, and I think that Dash.js is awesome. But YouTube is a very, very specific playback context. And one of the things that's great about Dash.js is that it deals with a diversity of manifest types and different kinds of file formats. And this diversity doesn't necessarily apply to a system that's more vertically integrated than YouTube, where the videos that play on YouTube and the content distribution network used for YouTube and the web front end is all sort of designed to work together. And so the YouTube player is a little bit different. It's basically not very portable. For YouTube, Dash is about portability. It's about interoperability. How is it that you can make videos play in as many places as possible? Can I get a show of hands? How many people in the last week watched a YouTube video? How many people watched a YouTube video on a desktop computer? How many people watched a YouTube video on a mobile phone? How many people watched a YouTube video on a game console or television? You see where I'm going with this. that the more environments that are capable of playing a consistent set of videos in a consistent way, the easier it is to make sure that you get the media that you want. And if you're a creator, the more that you can get your video out to people who want to see it. So for YouTube, media source extensions and encrypted media extensions are a big part of what Dash is all about. And the first step that YouTube took in bringing Dash to YouTube was setting up this page here. Has anybody seen this one, the MPEG-DASH media source demo page? This maybe is how YouTube and the Dash Industry Forum sort of met, because people at YouTube built this when it became clear that consumer electronics manufacturers who were interested, and browser developers who were interested in building things that supported media source didn't really have a very actionable reference. It wasn't really clear how to make it go. And so we built this, and you can see it's pretty plain. Let's see if we can get this thing to play. Where is that?
Click on car.
Click on car. There we go. Yeah, I was going to do. There's a good one. Go, 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 go. Oh my. Oh, there we go. So this turned out, it would be wrong to say this is more popular than we expected, because we expected it would be popular, but it had an interesting effect when this website came out, is that people started writing. And they would call, they'd say, this is really interesting. Could we use that player? And we're like, I mean, it's not that someone should own this player and that you can't have it, but this is not intended as a production quality system. So when people call now, we 302 them to Dash.js. Is it culturally appropriate to use 302 as a verb?
I love it.
How many people think 302 is a verb? Raise your hand. Okay,
I think it's culturally inappropriate to have to explain it.
So the next thing that we realized was that for browser developers and for consumer electronics manufacturers building their own implementations of media source and encrypted media extensions, that it would really help to have a place that you could download JavaScript, or even just a site you could navigate to where you could exercise tests. And so sure enough, here, this is, again, available on the internet today, are YouTube's media source and encrypted media extensions conformance tests. And these ones, you basically can just come here and click, and with your browser and see what passes and what doesn't. And what's fun is when a new user agent comes out that maybe you're not sure if they support media source extensions or encrypted media extensions or not. When you install that new version, then come over here and see if they have any surprises under the hood for you. Excuse me. Double clicking. An older version of the tests that are on there have actually been committed to the DASH.js repository, and they've been open sourced. So if you are interested in them, you can download them and run them and do with them, improve them, do with them what you will. All right. Here's another trivia question. Does anybody know what the first full public implementation of Dash for YouTube was? Common encrypted WebM VP8 on Chrome OS. How many people got the right answer? Raise your hand. I asked a question I didn't think people could answer because I wanted to highlight stuff that Jeff and Will had mentioned, where the Dash spec as a whole is codec agnostic, and that YouTube benefits from this portability because YouTube videos play back in a lot of cases, and there are a lot of different file formats and a lot of different codecs. So these videos still play, people still watch them, they look good. What are the most popular Dash-style playbacks on YouTube? Does anybody have a guess? This is a trick question, because the most popular Dash-style playbacks on YouTube are the most popular videos on YouTube. There you go. And so, for example, if you were going to look at what is among the most popular YouTube videos that plays in Dash today, I would say this one. And if you go into the stats for nerds here, you can see.
Dog goes woof, cat goes meow, bird goes tweet, and mouse goes squeak. Cow goes moo, frog goes croak, and the elephant goes toot. Duck say quack.
See if we can do that thing where we see the requests.
And the seal goes ow, ow, ow. But there's one sound.
And maybe I've watched this before, so I've seen the requests already.
What does the fox say?
There we go.
What the fox say?
All right. I could play this all day, and I do. But this video plays back using Dash-style techniques, fragmented MP4, AAC, H.264. It plays back in Chrome and in IE11 using the media source extensions. It plays back in Flash. This is a popular video. And I mentioned this because I was talking with a guy who works on the Chrome browser, and he's one of the product managers on the media stuff. And he said he went to a conference and someone pulled him aside and said, John, do you think this Dash thing's ever going to happen? And, without trying not to laugh, he's like, yeah, I think it is, because it already has. So if you're wondering, would someone deploy Dash media at scale, I think the answer is yes. So what's next for Dash at YouTube? What's next is VP9. Has anybody heard of VP9? VP9 is an open source next generation codec that YouTube has begun to deploy now. It's available for playback in Chrome. There are a bunch of consumer electronics manufacturers and chip developers who are working on it in the future in the way that those sort of industries work. And it's also being built into Firefox as we speak. And you can see it. By the way, do you guys know this trick? If you take a YouTube video and you right-click and you click on Stats for Nerds, then it'll tell you stuff like how many bytes were downloaded and what the MIME type is. In this case, you can see it's WebM VP9. So this is a great way if you watch a video and you're thinking, this looks awesome, what's inside? Then this is a way you can do that. Or if you think, this is busted, who are these people? Then you can also go in there and you can get a sense for how the videos are put together. And what's great about VP9 is that it offers it's a more efficient codec, it's next generation. So you get both higher visual quality and lower data rate. And at the rate that people are uploading and watching videos, this is a welcome relief. And for that, I bring it to Ross, because that's Dash at YouTube.
Excellent. Thank you. Okay, so I'm Ross Gardler. I work for a company called Microsoft Open Technologies Incorporated. We're a wholly owned subsidiary of Microsoft, and we work in the areas where open source and open standards are very important to what we're doing. We're focusing on interoperability, so everything that Richard was just talking about is very important to us, and it's very important to everybody in the MPEG-DASH environment. So I'm not going to talk so much about Microsoft specifically. I'm going to talk about DASH.js and how it's run as a project, what role you might have to play in it, etc. So to do that, I'm going to first look at why Microsoft are involved, and specifically why I, as Microsoft Technologies, Open Technologies, are involved. Simply, it's because Microsoft, the company, has lots of products that generate revenue for it. The slide up here is Windows Azure Media Services, which is an end-to-end solution: ingest, encode, package, encrypt, and deliver. But we need to be able to make sure, very much like YouTube, that we can deliver to every platform. And so something like Dash.js and MPEG-DASH is extremely important. But that's not the only business group within Microsoft. There are many others. We have places like Xbox that are producing video. We have places like SkyDrive where people are saving their videos and wanting to play them back. But more importantly as well, or at least as importantly, there's an ecosystem of people building solutions on top of these products like Windows Azure. So our focus here is entirely on interoperability, entirely on making sure everything can be played on every platform. So we invest in that, and I'll give you a live demo shortly, because that's what we're all doing. I've taken a different video. I've taken a video from TED, which somebody asked me earlier on, am I allowed to do that? It's Creative Commons by attribution, non-commercial, and non-derivative. I hope they don't consider this as commercial. It's not really commercial. It's showing you the open source implementation of this. The source format we have is MP4. And then last night, I ran that through Windows Azure Media Services and encrypted it so that I could play it back today as an MPEG-DASH file. So we'll come back to that shortly. So the challenges of Dash.js have been talked about a little bit, or some video over the internet really have been talked a little bit already. We have so many different devices out there, so many different operating systems. Being able to support all those increases costs, the cost of encoding, the cost of storage, the cost of distribution, the cost of players. There's just significant costs right across the board. So we need to reduce the number of different protocols and so on out there. And like pretty much everybody here in the MPEG-DASH and DASH-IF environment, we believe HTML5 video is the way to do that, and we've had an overview of MSE that enables that. So that's why we're involved as Microsoft, and I would suggest that's why anybody who's interested in video over the internet needs to be involved in some way. If you're not convinced by that, perhaps some numbers will. According to Conviva, who did a viewer experience report earlier this year, 60% of media streams in 2012 suffered from some form of quality degradation. And in that, of course, results in a lower user experience, a lower quality user experience. And that equates, according to Conviva, to a $2.16 billion loss of revenue. That's a pretty good reason to care about these things. So we need to change these things. We need to get that number down, bring up the user experience. And MPEG-DASH, as you've heard, is one approach, and I believe the most likely approach to succeed to this to solving this problem. There is an industry desire to support MPEG-DASH, and we've already heard it from people up here. The Dash Industry Forum did a survey last year. And these graphs, I'll tell you what they say because you can't read them, but these Dash, the top one is saying, yes, we are going to implement Dash, but we're being held back by the lack of availability of clients. Now, that's largely a perception issue because actually there's quite a lot of clients out there. And one of the things that DASH-IF did as a result of this is they put together a page on the DASH-IF website which will take you to the clients that you can get hold of and use. But one of the other things we did was say, well, let's make it really easy. And Jeff has already shown you how easy it is to use Dash.js to create your own player. It's permissively licensed, it's BSD licensed, so you can do anything with it, and you can use it as a reference player just to look at it and implement your own version if that's what you need to do like Google, or you can take that code and use it as is, or you can modify it as required. So we took steps to ensure that the problem of the lack of clients or perceived lack of clients went away. The other thing that was interesting, or one of the other things that was interesting about that survey was that those people who want to deploy want to support every platform. The graph here is just different platforms. Do you want to support this one? And you can see almost universally every platform needs to be supported. So HTML5 is the way that we can go about doing that. Because if we can get all of the major browsers to support MSE, we can then give them a Dash.js style player that will run in all of the browsers and therefore on all of the platforms, whether that be a set-top box, a mobile phone, a desktop computer, or whatever. So what if it were easy? Okay, this is going to be a repeat in a slightly different way of what Jeff did earlier on. So you've taken a TED video and you've encoded it in whatever way you want into an MPEG-DASH. How do you get that onto your website or available through a browser? Well, the first thing you do is you create an HTML page. Nothing special, just a standard HTML page. You add a video tag. Nothing special, just a standard video tag. You bring in the Dash.js code, which you can download from GitHub. You do what Jeff showed you earlier on. This is just a different way of writing the code that Jeff did. You start up the player and you configure it and you tell it to play. And you give it a bit of CSS. So there's nothing difficult about this. Anybody who's probably done 1 year of computer science at university, maybe even high school, can do this. Except me. Then you view in a compatible browser. And today, that's the sticking point. The compatible browsers today is IE11 and Chrome. Mozilla have undertaken to implement it in Firefox by the end of this year, and work is progressing very nicely over there, so we should have Mozilla first. So things are happening, there are more browsers coming all the time, and the level of interest is extremely high, and I have high hopes that we will have a much broader support as we move forward. So I'm going to give you a demo. So in this case, we're running, this is a Surface Pro, and we're going to run it in IE11 on the new modern interface. It's just warning me that I'm about to install a virus, which of course is not true, it's a video. Okay, I have to allow blocked content and a little bit of caching, assuming the network works. So there we go. We haven't got audio together. I just want to skip forward to 4 minutes and 20 seconds because this is cool. This is underwater. The guy's describing an underwater scene, and there's some algae there in the foreground. And he's talking about how animals and fish and so on protect themselves. Just watch this. That's an octopus. Okay, that is just amazing that they can do that. So that's not the point of the presentation. I just love that video. Okay, so that, as I say, I took an MP4 videos from the TED website last night, encoded it, and then you can play it by just, I used 8 lines of code, Jeff showed it in 6. Actually, you can do it in 3. It's the minimum I think you can do it in. So if anybody wants to have a competition about that at some point, we can have a go at that. So why are you important to Dash.js? The key thing here is that Dash is an open source project. Dash.js is an open source project. And everybody who knows anything about open source will know that open source, when it's successful, is not a free-for-all. It's not everybody coming along and doing whatever they want. It's neither is it a single organization saying, this is the way it will be. And it's not a business model. It's not a way of making money. It's a way of developing software with which we can make money in many, many different ways. There are many different business models out there. So what we need to do with Dash.js, and we're already very successful at this, we already have a significant number of contributors from different companies with different business models and different drivers, but we need more because we want full interoperability. We need testing across every platform. We need people to help improve performance on every platform. So the more we have, the better. We need to collaborate together and ensure that what we're producing through this shared development model is a common base product that we can all use. So Jeff talked about the algorithms for selecting which streams to bring down, what bit rate, etc. You can use the default out-the-box ones, or you can modify them and use those as a differentiator in your own project. So we need you to come in and test and work with us and build your business model around MPEG-DASH and hopefully Dash.js. We all need that interoperability, as we've said so many times. And I want to re-emphasize, Dash.js is an open governance project. When I was being introduced earlier on, it was mentioned that I'm president of the Apache Software Foundation. Apache is well known as a foundation in which competitive organizations can come to, organizations that are in competition with one another, can come together and collaborate. Well, that's what we're doing at Dash.js as well. We're ensuring that people who can compete in the marketplace can collaborate to bring us the interoperability that we all need. So we need you to come along. We need everything that you can bring us. Anything like your use cases, bug reports from testing the Dash.js, code contributions, everything. No contribution is too small because we need to get maximum input across every platform and use case. So to get to the project, to find out how to contribute, the aka.ms/dash.js is just a shorthand for the URL below there, which is the GitHub address. So on there you will find, on the front page, you'll find a link to information about how to contribute and how to engage. We're a very friendly bunch, so please come along and help us out.
Thank you very much, guys. Those great presentations. So I'll open it up to the floor for questions. I have a number of questions I will go ahead and ask, but I wanted to give you guys the opportunity to start asking some first. So does anyone have a question? Okay, I'm going to ask mine then. So, okay, well, here are my questions, too small, so nothing secret here. I got a question for each of you guys and then some general questions. So question for Jeff, since you haven't spoken the longest here. As a player building company, and you can speak a little bit about Digital Primates, why are you doing so much work in the open source community, and doesn't that undermine your core business?
So at Digital Primates, we're a consultancy that focuses on front-end development. We do a lot of video players, as Will mentions, and the reality is that we don't see this as at all antithetical to our business model. The reality is that by doing this, we gain expertise in this field, which makes us better able to serve our customers. We do a lot of consulting already around Dash.js to take this open source player and make it better for our customers and meet their specific needs. So as a consultant, I've got no problem at all being involved, being actively involved in open source projects like this. It actually helps our business. Great. Okay, Richard. Many companies trust Flash-based delivery and are a bit apprehensive about an MSE and a Dash approach. So you do a lot of A/B testing and metrics collections. How has MSE and Dash performed compared with your core Flash-based delivery in terms of quality experience for the end user?
How does MSE playback compare with Flash playback? It compares very favorably. It plays as well or better. It starts faster. And it's where a lot of community engineering effort is going to make rapid improvements. So based on technical quality and quality of experience, I think media source playback is a pretty good bet.
Good. Okay, Ross. Why, you mentioned interoperability a number of times in your talk. Why is that important? We have three formats, HLS, Smooth, and HDS, one of which Microsoft owns. So why is interoperability more important than continually pushing, say, smooth streaming as the sole format, for example?
Well, I think Richard covered that really well in his presentation. People want to watch their content on the platform that they choose to watch. And if we have 3 standards, such as the 3 that you mentioned, then in order to support all 3, you're having to increase your costs. So by reducing the number of standards and protocols in use, we can make it cheaper for people to deliver to the multiple platforms that are available. So we change the number of variables at the beginning, we change the number of variables at the end, we reduce the costs and improve the quality all around.
Good. Okay, another question for Jeff. What are the most commonly requested features your customers want from browser-based players that you're getting requests for today?
Interesting. So the main thing, of course, people want in browser-based players is ubiquity. They want things that are going to play everywhere. And unfortunately, media source extensions aren't there yet. So we still do a lot of flash fallback on our players. However, within Dash.js, the feature that is currently being requested most that's not fully supported yet is better support for live playback. Right now, Dash.js has limited support for live playback, but we're actively working at making more robust live playback.
Yeah, we should mention the 1.0 release is what you can grab today. It's good for VOD. It's the NSA, don't worry. The 1.1 release is coming out hopefully mid-December. Our fingers are crossed. That is all focused on live, because we want a live playback. The fact that you can get really well-functioning adaptive multi-bitrate live in your browser with 6 lines of JavaScript is a good one. And the fact that you can do it, just a vote for Google. I got the new Nexus 5, if you're geeky enough to get it. The default browser is Chrome. This project works beautifully right off the bat, just inside the browser. And that's going to be that way, I think, for Android. So I have a follow-up question, if you're ready for your Android question, for Richard. So Android KitKat was released with native video element support for HLS, whereas Dash has got an MSE type-based approach. So why the bifurcation there? And why not handle HLS and Dash the same way inside Android?
So I sort of speak as a developer here. I'm not so closely connected as to speak authoritatively on how that choice was made. Yeah. But for myself, I feel comfortable with this distinction because I think of HLS as being sort of unitary, and the intention of HLS is to be vertically integrated into the systems that support it, and that I think that Dash is designed to have that sort of customized application layer control over adaptive algorithms, over chunk fetching, over memory management. So to me, this just sort of seems natural that I have been involved in treating HLS in the same way and writing a sort of application level abstraction layer that it sits in between video playback and HLS manifests, and it's a bit of a nuisance. Like it's doable, I've seen it, but I don't think that that's how HLS was intended to be used. Whereas when I think about how Dash is intended to be used, I feel like it's meant to empower the application developer at that layer.
Great response, thank you. So Ross, I had another question for you, but you've already asked it, so I'm not going to answer it again in case anyone can read my eye chart. So I've got just 4 more general questions for our panel, and then we can go back. Anyone brave enough to ask their own question? Richard, go ahead.
The obvious question, which we ask a lot, is support for multi-channel audio in 3D content.
Ultimately, as far as Dash.js is concerned, so long as the underlying browser you're playing it in will support it, it is fully supported. In other words, I'm kicking the can into the side of the table.
In my opinion, this is a vote for greater standardization for capability definition around multi-channel audio. I'm not sure that CamPlay type is really exactly robust enough in its current form to support what it means to play multi-channel audio. That's my pitch for my brothers on the standards side.
I don't know why you're looking at me. I'm not standards either. I'm very much open source. Yeah, I mean, likewise, Microsoft's OpenText commitment to Dash.js is if it's in the AVC 264 guidelines, then it needs to go into Dash.js and be fully supported.
So yeah, with Dash.js, we're limited by what the browser can render. And we've had this discussion. So as soon as Chrome or IE or Opera or Firefox will support a Dolby, a DTS, or Fraunhofer implementation of multi-channel surround, we would love to implement it. And that is one of the drawbacks of browser-based approach, is we can't do some things that we want to do, and we're trading portability and ease of use for features.
And then I think you
Absolutely. A lot of the knowledge that we've learned from the Dash.js project, we've used to build Dash players for Android, for set-top boxes, for connected TVs. So the knowledge is very portable.
Yeah, I'd add the code is also very portable. If you're using things like Apache Cordova, which many of you may know better as PhoneGap, then you can use the Dash.js code inside of a PhoneGap Cordova-based application to run natively on the various platforms.
Okay, question? Yep. Let me repeat the question for the webcast. So the question is if the browser wants to support DTS, did you say?
I mean, currently, all the browsers doesn't support.
Yes.
Don't support DTS audio. So if we want to use DASH.js player to play that content with DTS audio,
then we can't. Well, the point is with Dash, you can put multi-channel tracks. So what DASH-AVC 264 says, there's a base layer which says you must at least put an AAC stereo track in there. But you can also add a DTS and a Dolby and a Fraunhofer multi-channel track as well, and the client chooses what it can play and it plays it. Exactly. So the Dash.js player introspects a browser, it hands it the MIME type and it says, can you play this? And the browser will say, no, I can't play that. And then it won't try to play it. So we'll ask the browser what it can render. The source buffer will throw an error if you initialize it with a MIME type that it doesn't, that it can't handle.
And I don't mean this to be flip, but if there's a user agent that doesn't support the codec that you want, perhaps the next thing to do is to make your own user agent that supports the codec you want. I realize this isn't straightforward for most people, but for example, if you have an industrial application and you'd like to build a kiosk that has a certain kind of support, that using the open source browsers and building your codec support into your application that way is a method I've seen work.
Okay, we're getting near the end, so I'm just going to ask one more question to each of the panelists, and then we'll be done. And the question is, since we're approaching Christmas, what would be your 2014 wish list for either MSC or Dash? What features would you like to see enabled by browsers or across the ecosystem that pertains to some of the subjects we've handled today? Jeff first.
Thanks. So the main thing I'd love to see out of MSE really is just more ubiquitous support. I am looking forward to seeing it in Firefox, in Opera, maybe someday Safari as well. That's more than anything what I'd love to see.
Okay, Richard?
We may all have the same wishes. I was going to say I wish for 5, right? Five major user agents that support MSE would be good for me, and certainly implementation of the forthcoming newer versions of the spec that give slightly finer grained control over memory management. That would be nice too.
Yeah, we definitely all want the same thing for Christmas. We need support so that we can accelerate adoption of MPEG-DASH, but I'd also like a pony, please.
Okay. I'd like to make Ross happy. I want to thank everyone for your time today and listening to us, and please join me in giving my panelists a round of support. We'll be here for a little while longer. If you have questions or you're shy, come on up and we'll answer them. Thanks.